In this sequencing series, we are asked to expand the series and evaluate. Now, we have a new symbol that we might not be accustomed to here in this particular problem. And that's called, it's a Greek letter, it's called sigma. And what sigma means, it means to sum or add. So essentially what we're going to do is we're going to crank out the different values of this sequence from 4 to 8 and then add those together. And we're going to use this. This is actually our formula part of this. So we're going to start out, and this always tells us our starting position. In this case, K is going to start at 4. So that means the first part of that says to expand. So that's what we want to do. We want to expand this. So when K is equal to 4, then that means with our equation we're going to have 4 over 4, which is equal to 1. Now, we're just in the expand phase of this. Keep that in mind. Then we increment 4 on up to 5, so then K is going to equal to 5, and that's going to give us 5 over 4 in this series or sequence. And then we're going to increment K on up to 6, and when K is equal to 6, then our formula is going to give us 6 over 4. And typically with our fraction, we'd want to reduce that, but in this case, we're going to leave it because we want to add all these up. So I'll get back to that in a minute. Now we're going to go on and increment K one more time. K is going to go to 7, and that's going to give us the fraction 7 over 4. And then one more time, we're going to do this one more time because it tells us to go when that is equal to 8. So the next time we increment that, K is going to be equal to 8. So K is equal to 8. That means our formula is going to give us 8 over 4. Now, the sigma part of that Greek symbol, means that we want to take each one of those and add them together. Add them up. That's what sigma means. It means to sum or add up. So the first one was 4 over 4, plus the next one was 5 over 4, plus 6 over 4, plus 7 over 4, plus 8 over 4. Now, the reason why I didn't reduce these fractions is because, if you recall, in order to add fractions, you have to have a common denominator. And so it would have just made more work and kind of defeated the purpose if we'd have reduced these, because we'd have had to come back and got the denominator back. So you can go through all that. So now it's just a matter of adding these up because I have the same denominator in each place, if you'll notice. So now I'm going to add the numerators. 4 plus 5 is 9, plus 6 is 15, plus 7 is going to be 22, plus 8 is going to give me 30. So I'm going to have 30 over 4. And now I can reduce that. I can make that into what's called a mixed number. Well, first let's reduce it. I know that both of them have a common factor of 2. So 2 goes into 4 2 times, and 2 goes into 30 15 times. So that reduces to 15 over 2. But that's an improper fraction. We want to make that a mixed number. So we divide the denominator into the numerator. So 2 goes into 15 7 times, which gives us 14. 15 minus 14 gives us 1 left over, so it's going to be 7.5. So if we go back to our original equation, or our summation, actually, it's not really an equation. It was when K is equal 4 to 8 of K over 4. We want to add that sequence or that series up. The sum of it all is going to be 7.5.